Hi there, I'm Mr. Wang and welcome to my video. Today, I'm excited to dive into the world of SACE specialist maths. In this video, I will use specialist maths divisibility tasks to demonstrate two key things. Firstly, specialist maths is not as hard as many students may believe. Then, thinking inside the box is equally important as thinking outside of the box. This video is perfect for students already in SACE Specialist Maths course, or Year 9, Year 10 students who are considering enrolling in this subject. After this video, you should be able to understand the use of techniques in mathematical problem solving. Then, be able to solve all SACE Stage 2 past examination divisibility questions correctly, concisely, and in line with the A band of the performance standards. Join me, let's get started. Before we start, I want to invite you to reflect on how the concept of division has been introduced and developed. We started our journey with division in Year 3. By the end of primary school, students should have a solid foundation in division. Then, in Year 7, the emphasis shifts to formal division methods and applying mathematical techniques, such as divisibility tests, which will be an example later. In middle school, division becomes more abstract, introducing concepts like algebraic division. In senior years, the focus extended to more advanced techniques such as polynomial division, synthetic division, and divisibility tasks in Year 12 specialist maths. However, all these are just techniques that stem from the basic division concept learned in primary school. Let's use Year 7 divisibility as an example. So teachers use activities similar to this to introduce divisibility tests for natural numbers. Then, students just need to select and apply these techniques to solve problems. For example, if we look at this big number, and you want to find out whether or not this number is divisible by 3, then we just need to find out if the sum of these digits is divisible by 3. So we look at the first two digits, which is a multiple of 3, and the middle digit is another multiple of 3. The final two digits is a multiple of 3. Then we can confirm that this number is divisible by 3. We don't have to carry out the division and we save enormous amount of time if we apply and select use technique appropriately in a test or an exam. Now we are going to use Year 12 content induction divisibility task to practice this skill. And highly effective selecting and applying of mathematical techniques is part of the performance standard. So don't be afraid of thinking inside of the box. For induction questions, we start with the first proposition. And from here, we can see that the first proposition is P0, which means we use n is 0 to substitute this expression. Then we get 2 to the power of 2 plus 3 to the power of 0, which is 4 plus 1, and is 5. Now we want to make it super clear. 5 can be factorized into 5 times by 1, which means divisible by 5. Therefore, P0 is true. Then we make our assumption. We assume when n is k, this expression is divisible by 5, which means it can be factorized into 5 times by I, where I is an integer. We do not need to have k is integer, because we already have here n is k, and then n is an integer. Now we look at pk plus 1, which means we use k plus 1 to substitute n for this expression. Then we get something like this. Now we need to substitute the assumption and use the assumption to prove that k plus 1 is also true. Look at the assumption, the highlighted in yellow one. The way we use it is to rearrange the this expression to look like the highlighted in yellow one. Then what I would do is to split the power. So I would split this power, and I would split this power. This one is literally 1 times by 3, because you have a 3 in front of the bracket. Then I split them into 2 to the power of 1 times 2 to the power of k plus 2, and 3 to the power of 3 times by 3 to the power of 3k. Now, what I would recommend to my students is that you do not need to overthink. You just need to write down your assumption here. Okay, so you just write that down, and then you sort of free your brain working note, and then if this is a plus, you go to the inverse operation. You write a minus, because this is because you plus a 3 to the power of 3k, and then you introduce something else to this expression, and you want to balance off by subtract this part. And you just need to be careful with the there is a 2 in front, because this 2 there is a 2 outside of the bracket. Alright, then you substitute the yellow part as 5i here, and then let me use this color, the blue color. This part, you collect the like term, and you get 25 times by 3k, 3 to the power of 3k. Now, obviously, we have a common factor here, 5, and a common factor 5 here. So 5 times by 5 is 25. Now, we factorize this common factor 5, and then use a bracket to include so the 2i and the 5 times by 3 to the power of 3k. Since I is an integer, and 2k plus 3 times by 3k is also an integer, therefore pk plus 1 is true. So the strategy I introduced here is the substitution part. From here to here, you can always use this strategy for all the divisibility tasks. And the majority of the time, you only need to think inside of this box. You do not need to overthink or be creative in tests or exam. However, in your day-to-day practice, you can explore as many techniques, strategies as possible, and develop your own one. Now let's look at 2023's examination question. So it's question 4 and 7 marks. So prove by mathematical induction that this expression is divisible by 9 for all positive integer. Now from the last piece of information, we know that n starts with 1. Then we use 1 to substitute n for this expression. Then we get 4 plus 15 minus 1 is 18. And then we factorize into factor of 9, 2 times by 9. Then P1 is true. Then we make our assumption that Pk is true, which means when n is k, this expression is divisible by 9. Divisible by 9 means can be factorized into 9 times an integer, and this integer is I. Now let's look at pk plus 1. So we use k plus 1 to substitute this expression, and we get this one. And then, because I said that if we want to use our assumption to substitute, we need to rearrange the expression to look like the assumption. Here, I would split the power, this one, into 4 times 4k. And then, remember I said that you do not need to overthink. You just need to write down your assumption to be here. And then you just apply the inverse operation because you introduce something, because originally it was 4k, and then you introduced something else like plus 15k and minus 1. You need to balance that expression. So you need to, if it is plus here, you need to minus. If it is minus here, you need to plus. And then here is minus 1, and we have a 4 in front of this bracket. So 4 times this minus 1, and inverse operation, so you plus 4. And here 4 plus 15k, so which means you minus 4 times by 15k. And then you substitute, let me use the blue one. So this is our assumption. You substitute the assumption into 9a, and then you just need to collect like term. So here, this part is negative 6k, and then we have a plus 15k, so in total negative 45k. And with numbers, we collect like term that's positive 18. And then we found that there is a multiple of lines. So here is a line here. So this one is 9 times by 5. And this one is 9 times by 2. Then we factorize, put the line in front, and use the bracket to write to include the remaining of the factors. And then we prove that the bracket is an integer, so it's an integer. Then pk plus 1 is true. So everything is the same. If you look at all the past past examination questions, they are highly similar. Now, I would like you to pause this video and to use this strategy to solve the divisibility question for the past examination questions, so 2022 and 2018. The technique I introduced you can also be used to solve the following up question in 2023's examination. So the question B, by using question I to solve that, so we consider the question I is an assumption And then we just need to rearrange the 4 to the power of n plus 1 to look like your assumption. What I would do is to obviously split the power into 4 times by 4 n, and then I straight away use a bracket to write down what I want. So that's the assumption. So you just need to write, and you free your working memory load, and then you just need to do the opposite. So minus a 6k n. This is because 15 times by 4. And then here is minus. You need to plus 1 times by 4, so which is 4. Don't forget that you still have this part. So you write down this part here. So I have plus 60 n and minus 1. Then what we need to do is to substitute and simplify. Here's the question I, we have proved that it's divisible by 9, which means I substitute the bracket as 9i, and then here I collect the like terms. So we got negative 60n and positive 60n. So we have a 0, and then we plus 3. Now we can see that there is obviously a multiple of a common factor of 3. So I put 3 in front. What inside would be 4 times by 3i. I do not even bother to simplify, and I can put a 0, but it's a bit unnecessary, and a plus 1. Alright, so we can prove that, since I is an integer, the bracket is also an integer. This means this expression is divisible by 3, and we prove that. This is a 2020's examination question. It does need you to think a little bit outside of the box for the 2 following up question. And it's 1 mark, another 1 mark. With the 2018 one, for the following up question, again, you need to think a little bit outside of the box, and 2 marks. To wrap up this video, I encourage you to view mathematics as a science subject, characterized by patterns and systematic thinking. With this perspective, let's consider 3 questions. First one, how likely do you think the divisibility questions will be in 2024 Specialist Mathematics examination? My students and I have predicted this year's questions, and I'm sure you can see there is a pattern of frequency. Question 2. If the question does come up in 2024, how many marks in total? How many marks for the following up question? Question 3. I'd like you to predict the question booklet number and the question number of divisibility task. So with these questions in mind, I hope they guide you towards more informed decisions in your learning and exam preparation. Finally, the goal is for you to gain exceptional confidence in your exam performance.